Welcome to a space where ideas spark curiosity, questions ignite answers, and inspiration transforms lives. This is Mind Alchemy, your destination for unlocking potential in everyday life. Hey there, code enthusiasts. Are you ready to unravel some AI magic? Today, we're diving into the mesmerizing world of tokenization with Hugging Face's Transformers library. But here's the twist. Tokenization isn't just about breaking down text. It's an evolving science. In this video, we'll uncover how newer tokenizers are refining their behavior to boost model performance. So, grab your coffee, buckle up, and let's embark on this colorful journey into the heart of AI text processing. Let's get started. Here's the text we're working with. It's packed with a variety of elements that will help us explore how each tokenizer handles different kinds of tokens. Let me break it down for you. Capitalization. Does the tokenizer care if words are capitalized? Languages other than English. How does it handle non-English characters? Emojis. Will these tiny icons survive the tokenization process? Programming code. We've included some code snippets with keywords and white spaces, just like you'd see in Python, to test how tokenizers manage structured text. Numbers and digits. Do numbers get split into smaller parts or stay intact? Special tokens. These unique tokens serve specific roles, like marking the beginning or end of a sequence or triggering specific behaviors in a model. Now here's the plan. We'll take a journey from older tokenizers to newer ones, analyzing how they break down this text and what their choices reveal about the underlying language models they support. So let's dive in and see how LLM tokenizers interprets this eclectic mix. First up, we import the necessary libraries. Hugging Face Transformers gives us tools for both tokenization and language modeling. Auto Model for Causal LM loads causal language models used for generating text. Auto Tokenizer automatically fetches the tokenizer for the specified model. Let's run the cell. To make things visually engaging, we've got a list of colors. Each token will pop out in a different shade. This list contains RGB color codes as provided here in this snippet. Each token's background will cycle through these colors for clarity. This color cycling will add a fun layer to the tokenization visualization. Here's the heart of the script, the show tokens function. It takes a sentence and a tokenizer name, then displays the tokens in vibrant colors. Sentence, the input text to be tokenized. Tokenizer name specifies the tokenizer to use. Tokenizer sentence, input IDs, converts the sentence into token IDs. Enumerate token IDs, iterates over tokens, tracking their order. Colors list, cycles through colors for each token. Let's execute this cell. Here is the text we are working with, which we previously discussed at the beginning. Let us proceed with running the cell. Now comes the exciting part. Let's explore how different models tokenize this text, starting with the 2018 BERT base uncased model. With the uncased version of the BERT tokenizer, we observe the following. New line breaks are removed, making the model unaware of information encoded in new lines. All text is converted to lowercase, as the tokenizer is case insensitive. The word accentuation is tokenized into two subtokens, accent and hashtaguation. The hashtag prefix indicates that the token is a continuation of the preceding token. This also implicitly marks spaces, as tokens without a hashtag prefix are assumed to have a preceding space. Emoji and non-English characters are replaced with the Yoink special token, signifying an unknown token. The cased variety of the BERT base model, also released in 2018, can now be tested. The cased version of the BERT tokenizer differs primarily in its inclusion of uppercase tokens. Notably, accentuation is represented as 6 tokens: ACC, #EN, #TU, #AT, #ION. Both BERT tokenizers wrap the input with a starting CLS token and a closing SEP token. These are utility tokens that serve specific purposes. CLS stands for classification and is often used for sentence-level classification tasks. SEP stands for separator and is used to distinguish between sentences and tasks requiring multiple inputs. Next, we explore the GPT-2 model, released in 2019. With the GPT-2 tokenizer, the following observations can be made. New line breaks are preserved in the tokenized output. Capitalization is maintained, and the word accentuation is tokenized into 4 tokens. non-English characters are represented by multiple tokens each. Although these tokens may appear as question mark characters when printed, they actually correspond to distinct tokens. A single tab is represented as a single token, whereas 4 spaces are tokenized into 3 tokens, with the final space forming part of the token for the closing quotation mark. Next is FLAN T5, released in 2022. The FLAN T5 family of models uses the sentence piece method. We observe the following: no newline or whitespace tokens, which could make it challenging for the model to handle code effectively. Both emoji and Chinese characters are replaced by the unknown token, rendering the model completely unable to interpret them. This time, we test with GPT-4, released in 2023. The GPT-4 tokenizer behaves similarly to its predecessor, the GPT-2 tokenizer, with some notable differences. 4 spaces are represented as a single token, improving efficiency in handling whitespace. The Python keyword if has its own dedicated token, reflecting the model's enhanced focus on code alongside natural language. Fewer tokens are used to represent most words, making tokenization more efficient overall. Finally, we test the StarCoder 2 model, released in 2024. This 15 billion parameter model is specifically designed for generating code. A key difference from the models we've examined so far is that each digit is assigned its own token. The hypothesis behind this approach is that it enables better representation of numbers and mathematical operations. And there you have it, tokenization brought to life with colors and creativity. Experiment with different models and explore how they handle your favorite text. If you found this tutorial helpful, like this video, subscribe for more AI tips, and share it with a friend. Check the description for links to our Udemy course for automating your daily tasks with generative AI, and I'll see you in the next video.